Hello everyone, I'm Sean Billings from Billings Surveying and Mapping in Stumpwater, Texas. Today we're going to be talking about base rover setup with the Javad J-Field software using Triumph LS. You'll notice at the bottom of the screen the date that this was performed was Thursday, January 8th, 2015 using J-Field version 1.10.3.18939. This is significant because the software is still in development and over time some of the features that I mention here could change, so just be aware of that. First, as we discuss base rover setup, the first thing we want to do is build a rover profile under setup. So you want to go to home page 1, the first home page, and then select setup. Here the first setup that shows is the default setup, which we don't want. We want to set up a rover UHF profile. So I'm going to hit create right here. Asks me, do I want to create a new setup? I hit yes. It prompts me for a name and then takes me to the operating mode. We want to select RTK rover. That's what we're setting up. We're going to go ahead and set it to fixed so that we only get fixed results from the LS. We're going to set the minimum number of engines to 2. We're going to set it to start with start button. Of course, you can change that at any time as you're working to whatever start and stop method you want. I've got it set to start with start button and stop with stop button for now. Very important, base reference frame. If you're surveying in North America, most likely you're surveying with NAD 83 2011 as your base coordinate, so very important that you set NAD 83 2011 for your base reference frame. We're setting up a UHF rover, so we want to set the RTK corrections to UHF. Region all, channel bandwidth for North America 12.5 kilohertz. Next, the UHF frequencies. This would be the frequencies that you are licensed to with your FCC UHF radio license. UHF protocol, Javad. Modulation, DQ-PSK, which just sets that link rate. For communication, forward, error correction, and scrambling are both checked on. RTK, RTCM 3.0 message format. And I've got record GNSS data, this is talking about for the rover, unchecked, so that it will not record data at the rover by default. It returns to the setup screen, and now the current rover setup is the rover UHF that we just created. And now we're ready to go back to the home screen and select base rover in the upper right corner. Here we see this connect button, which is talking about the Bluetooth connection between our Javad rover and the Javad base. Notice below we have no connection here. This field is discussing the UHF communication between the rover and the base. This is what we're ultimately going to work for, but it has nothing to do with our Bluetooth communication, so even though you see connect and no connection here, these both represent two very different things. So we're going to hit connect here. Already the Triumph LS has identified that there's Javad Triumph 2, serial number 00016, in the vicinity. I press connect, and it reveals a new screen with the pin number, the default being 0000. If you have trouble connecting, typically that pin is 0000 or 1234. You can try either one of those if you have difficulties. If you still have difficulties, it would be prudent to connect that Triumph 2 to NetView and see what the pin number is there. I hit connect and proceed forward. After a few seconds, it displays connected to Javad Triumph 2 00016. Pressing OK takes us back to the base rover screen, and we see that the two fields on the right are now retrieving data, as we'll see in just a moment. Once that data is retrieved, the connect status goes to disconnect, showing that we are in fact connected by Bluetooth to the Triumph 2. The coordinates have been updated now to show the current coordinates for the broadcast corrections and the current antenna height and antenna height type of the base. Before we get into that though, we really want to look over here at the communication parameters. Notice that they are all in yellow, indicating that the rover and the base are both configured with the same parameters. If any of these parameters differed between the base and the rover, that parameter would show up in red, but because these are all in yellow, we can see at a glance that they are set to be the same. Pressing this field will now take us to the communication parameter screen. At the top we see base ID. This is simply to prevent the rover from accepting corrections that are coming from another base using the same correction parameters but from a different place. We want to make sure that we're using our base, and if you're concerned that there's another base in the vicinity that you might be getting corrections from, the LS will ignore that base and only listen to base corrections from this particular base ID. What I'm particularly interested in at the moment is the UHF configuration. Pressing that takes us to this screen, and before we can do any work, the LS wants to identify what the external UHF modem is for the base receiver, and it queries the base receiver to ask it what external modem is in use. After a few seconds, the result comes back. I was in fact using an HPT 404BT 4-watt Bluetooth radio modem attached to the Triumph 2, and this is significant because it allows us to only have options that relate to that 4-watt radio. Going to the frequency, we see our library of frequencies that we have programmed into the Triumph LS. If we hit scan, Javad's done a great job of allowing us to scan particularly those frequencies that are in our library. Instead of waiting to scan the entire bandwidth there, we're just scanning these particular frequencies, and he reveals a chart that allows us to visualize what kind of interference we may be expecting on those frequencies. Across the bottom we see the frequencies from our list. The red one is identifying the current frequency that we're broadcasting on, and you notice that all of the bars are very low, well below the minus 110 dB threshold. If it got above that threshold, we'd be experiencing some noise, and if it got above that minus 80 red line that you see there, we'd really be experiencing some significant noise, and we would want to avoid that frequency. But since we see that all the charts or values are good, we return back to the library and select frequency. Where it shows good here, had those frequencies been occupied by some other broadcast, we'd see that good show either noisy or avoid depending on the severity of the interference. Since they're all good, we're going to continue with our 464.55 frequency. And going back to this screen, we want to set our output power now from 1000 milliwatts or 1 watt to 250 milliwatts or 1/4 watt for this example. So we press that output power button and select the 250 option. Once satisfied, we return back to the base rover screen, and now we see that the output power is in red. That's because in the rover it's set for 250 milliwatts, but in the base it is still set for 1000 milliwatts. So what we want to do is press the to base button. This will send these parameters to the base, and now we see after that the output power is yellow, indicating that both parameters for the base and the rover are in agreement. Now then, if we wanted to mimic the parameters currently in the base, we could just hit the from base button and it would grab whatever parameters are in the base and make those current. This may be really handy if you have two rovers and you want to configure that second rover quickly off of the base. you would be able to just simply hit from base, and immediately you would have the parameters that the first rover set the base to. Generally speaking, you will be using the to base button more so than the from base, but both are available to you. Next, we want to edit these coordinates. These are the current broadcast coordinates for the base. Notice that they indicate to be too far from the current position of the base receiver. The 2D delta warns us if we have coordinates that are in excess of 10 meters from what the current autonomous position of the base is. So this is a great blunder check to make sure that you're not attempting to use the coordinates from the job you did yesterday that's 10 miles away. The JField software will not allow you to do it, and will warn you that that the coordinates that are currently set to be broadcast are in error. They're too far. So selecting this field right here, anywhere inside the square, takes us to the coordinate page. Now we can hit from list or enter or auto. From list allows us to recall a coordinate from a point that's already in the JField database. Enter allows us to manually enter coordinates, and from auto allows us to use an autonomous position, the current autonomous position of the base. Notice that the broadcast reference frame is still NAD 83 2011 as we had it set up in our rover profile. Next we hit send to base, and it asks us, do you want to send this coordinate to the base? At the bottom it says yes, store point, and send to base. Every time that you do a base rover setup, you will be forced, it is mandatory, to store a point. So we can consider that every base point attaches to a base session. And so you may have quite a few base points if you occupy a particular base point over several sessions. You may wind up having several coordinate points in your database that all reference the same base position, but they identify different base sessions. Here I've edited the page from page 2 to page 0, and then I hit yes, store point, and send to base. Now we see that those coordinates have been updated, and the 2D delta is now 0.13 feet. This will continue to change as the autonomous position continues to float, but it should stay within a few meters of this coordinate. Next we want to enter the height that's set to 4.85 slant, and I want to put in 5.0 foot slant. So we press that button, change the antenna height to 5.0, and hit send to base. Now we see that that value is updated in the setup, the base rover setup. And finally, the last thing we want to set is the recording interval. Pressing that upper button on the right, we see the recording interval option. I've got it set to 30 seconds to reduce the base file size. 1 second is great for kinematic operations, but for simply positioning the base using Opus or Jawad's Depot software, it makes for a very large file for us to have to download. So I have it. Returning to the base rover setup screen, now we are ready to press start base. At this point we see the button change from start base to stop base, and we see this dial begin to turn, powering it, which is indicating that the internal UHF modem for the rover is being powered up, and we can see the rainbow go from gray to blue to indicate that it's being powered up. Still we see no connection. Following no connection we see waiting, and finally we see receiving, and we see the inverted rainbow indicating that we're now receiving UHF corrections from our base. This would indicate that we now have success, and we'll go to the collect screen and see how the processor is doing. There we see that we have 6 engines fixed, and we have good reception, and we've got a fixed baseline and we're ready to work.